Now that we are familiar with converting U.S. customary and metric units, let's take a look at a more involved problem where we have to convert not one, but two units. The unit conversion process will be exactly the same, just convert one unit at a time. We can daisy chain as many conversion factors together in order to convert to the appropriate units. Take a look at the following example. A decent Major League pitcher can throw a baseball 90 miles per hour. How fast is that in feet per second? We know we're trying to come up with feet per second, and we know that we begin with 90 miles per hour. It does not matter which unit we convert first. Let's take a look at converting miles to feet to begin with. We know that there are 5,280 feet per mile, and in 1 mile there are 5,280 feet. Now let's take a look at converting hours to seconds. Most of us cannot recall how many seconds are in an hour, but we do know how many minutes are in an hour and how many seconds are in a minute. 1 hour is equivalent to 60 minutes, or is 60 minutes equivalent to 1 hour? Which one is the appropriate conversion factor? If we want hours to disappear, again, they must appear in opposite parts of the fraction. If we want minutes to disappear and seconds to remain, they must appear in opposite parts of the fraction. The major value of this unit conversion method is that it gives us a way to make sure the answers to problems come out with the appropriate units that we are expecting. Before you actually perform any numerical calculations, ensure that all units cancel out appropriately. Miles canceled to feet, hours canceled to minutes, minutes canceled to seconds. We see a Major League fastball clocked at 90 miles per hour travels at 132 feet per second. Try the next example on your own. Your utility company charges 15 cents per kilowatt hour of electricity. How much does it cost to keep a 100-watt light bulb on for a week? Pause the video here before moving to the solution on the next slide. Remember, it does not matter which unit we convert first. Our goal is to find a way to be left with only the cost, or dollar amount, of keeping this light bulb on for a week. Notice our final solution is the cost or dollar amount, so kilowatts and hours, those units must disappear in this process. We know that 1 kilowatt is equivalent to 1,000 watts. We are going to be using a 100-watt light bulb. It's going to remain on 24 hours a day over the course of 7 days a week for 1 week. Double check to make sure that all of your units cancel out appropriately, and the only unit that is left over is the dollar amount. We know we're on the right track, so we see that electricity for this 100-watt light bulb on for a week would be $2.52. Units raised to powers. We must take special care when converting units raised to powers. Suppose we want to know the number of square feet in a square yard. We may not know the conversion factor between square yards and square feet, but we do know that 1 yard is equivalent to 3 feet. Therefore, we can replace 1 yard by 3 feet when we write 1 square yard. Turns out 1 square yard is equivalent to 9 square feet. We can also find this conversion factor by squaring both sides of the yard to feet conversion. We know that 1 yard is equivalent to 3 feet. Mathematically, by squaring both sides, notice we're going to square both the number and the unit on both sides. That 1 square yard then is equivalent to 9 square feet. Let's take a look at an example. You want to carpet a room that measures 10 feet by 12 feet, making an area of 120 square feet. But carpet is usually sold by the square yard. How many square yards of carpet do you need? We know that we're looking for square yards in our final solution, but we begin with 120 square feet. Just like before, we need to determine the appropriate unit conversion factor. By taking a look at the units, we can decide which one is appropriate. 1 square yard is equivalent to 9 square feet. Our units of square feet are in opposite parts of the fraction, thus they will cancel when we multiply straight across. We see that 120 square feet is approximately equal to 13.3 square yards. Please pay attention to the directions of My Math Lab, a quiz, midterm, or the final. Most stores will probably only sell whole square yards. If this is the case, how many square yards would we need to carpet the room? 14. Try the following on your own. You are preparing a vegetable garden that is 40 feet long and 16 feet wide, and you need enough soil to fill to a depth of 1 foot. This means that you will need 640 cubic feet of soil for your garden. The landscape store only sells soil by the cubic yard. How much soil should you order? Pause the video here before moving on to the solution on the next slide. We know that we're looking for cubic yards, and we begin with 640 cubic feet. We have yet to discuss cubic conversion, so we need a new conversion factor. We know that 1 yard is equivalent to 3 feet. If we cube both sides, recognizing that we're going to cube both the number and the unit, we can come up with our new conversion factor. 1 cubic yard is equivalent to 27 cubic feet. So which unit conversion factor is correct? Right, 1 cubic yard is equivalent to 27 cubic feet. Our units of cubic feet are in opposite parts of the fraction, and thus will cancel out. Multiplying this fraction straight across, we see that 640 cubic feet of soil is approximately equal to 23.7 cubic yards of soil. Again, in the real world, you would need to order 24 cubic yards of soil for your garden.